Okay, so this video gives the solution of the function test that I had with my students. You can pause the video in between to do the sum on your own, try it on your own, and work it out. So the solution starts now. For the first one, you've been given a function, a quadratic function which you define. A quadratic function fx is defined as 2x squared minus 8x plus 6, where x is greater than or equal to k. Find the smallest value such that f inverse exists. Remember, quadratic is many to one function. So if a quadratic is a many to one function, you have to find out the minimum. So that means for the values of x greater than or equal to k, so if you take only this much, it will become a one-to-one function and the inverse will exist. That's what the question is. So we need to find out this vertex, the x coordinate of the vertex. Now there are a number of ways of doing it, but since this equation is in standard form, you can say the x coordinate is equal to minus b over 2a. So that is equal to minus your b. So from this you can realize that a is equal to 2, b is equal to minus 8, c is equal to 6. So minus b over 2a. So that's 8 over 4. So that's 2. So that means the value of k is 2. So when your x is greater than or equal to 2, the inverse will exist. So that's my first part A. Now part B, you have to find out this inverse. So what I need to do is I need to write the function as y is equal to 2x squared minus 8x plus 6, and I have to write x is greater than or equal to 2. Now whenever you find the inverse, what is very important is you have to first thing is, whenever you have like this, you convert this into the vertex form. Now I know my x coordinate of the vertex is 2. Now to find the y coordinate of the vertex, what I do is I just substitute this in the equation, in the original equation, and I'll get that. So 4 to the 8 2s are 16, 8 and 6 is 14, and minus 2. So my vertex becomes 2 minus 2. So that means if you want to convert this into vertex form, this will simply become 2. 2 is my coefficient, the coefficient of x by 2, x minus 2 the whole square minus 2. Correct? So this becomes the vertex form, and obviously this is defined when x is greater than or equal to 2 because of to make it a one-to-one function. You can also use completing the square method, but you may use this method as well, which is easier. Remember, in this video I may not be discussing all the methods. I will discuss only the easiest method, which will help you to achieve the solution. Now you have to find the inverse. So I am here to find the inverse. So I will replace x with y, y with x. And obviously when I replace y with x and x with y, I have to also replace the domain. Now this is what some children miss out. And if you miss this out, you end up losing marks. Now you have to make y the subject. So you get this on this side. Minus 2 equals plus 2. This continues. I am not writing it again. So you will get x plus 2 upon 2 is equal to y minus 2 the whole square. Therefore, y minus 2 is equal to plus or minus root x plus 2 upon 2. Yeah, so we are continuing y is greater than or equal to 2. So y is equal to 2 plus or minus root x plus 2 over 2. So y is greater, since your y is greater than or equal to 2, my inverse becomes 2 plus, because it's 2 plus. It's greater than or equal to 2. Now this is how you justify your working. Now many people don't write this, but they lose marks then. Now there's an implied domain. Now whenever there's a root sign, the thing inside the root sign should be greater than or equal to 0, because root for negative number doesn't exist. So you know that this value is inside the root sign. So the value inside the root sign should be greater than or equal to 0. So this is what we get is the implied domain. So this would be your complete answer of the inverse. If any one of these parts are missing, your marks would be missing. Correct? Yes. So this is what it becomes. So x is greater than or equal to minus 2 is the domain. So that answers my, I'll write it over here. That answers my part 2 also. So domain in range of f inverse. So domain, we got that x is greater than or equal to minus 2. Acha, range, your range of inverse will be the domain of the function. So my domain of the function is x is greater than 2. So my range here would be y is greater than or equal to 2. So the domain of the function becomes a range of the inverse, but obviously you write y over here because it's a range for the inverse. That's how you get it. Part 3 is what many children got wrong, and I do not stress upon the fact that whenever your function and the inverse intersect, they have to intersect on y is equal to x. So remember, a function and its inverse will always intersect in y is equal to x. So rather than equating the function and the inverse, you can equate the function to x directly, or you can invert the inverse to x. So that will make it much easier. So my function is 2x square minus 8x plus 6. You make it equal to x. Transfer all terms on one side to get your quadratic equation. Now now remember, my function is defined when x is greater than or equal to y. I did not forget that. I did not forget that. So that domain is always there. You have to make it a one-to-one function. So if I a is equal to 2, if I use the quadratic formula, so x is equal to minus b plus or minus root b square minus 4ac, 4 to 8, 6 8 b square, sorry, my b is minus 9, beg your pardon, 81 minus 4, 8, 6 8 are 48 upon 2a, 2 2s are 4. So if you solve this, you'll get two solutions, 2 plus or minus root 33 over 4. But I know my x is greater than or equal to 2, so I have to discard one of the solution. So my final answer should be only x is equal to 2 plus root 33 over 4. So you need to pay attention to all details. Then you get full credit. You may pause the video again to do the next sum on your own. But if you have already done the sum, I am showing you the solution. The solution starts now. So part A is you have to find out G inverse of fx. Okay. So first what will I do is G inverse of fx. So let me first find out G inverse. So to find out G inverse, what I do is, my G is, this is G. Obviously x is not equal to 1, the domain, implied domain. So replace x with y with x. Cross multiply, open the brackets. You have to make y the subject, so transfer all terms with y on one side and x on the other side. Remove y common. So I'm writing it, this is x plus 1. So y is equal to x plus 1 upon x minus 2. So therefore my G inverse becomes x plus 1 over x minus 2, with the implied domain being x is not equal to 2. That's my G inverse. Okay. Once you get G inverse, now we have to find out G inverse of fx. So my G, I'm writing it here, G inverse of fx. Correct? So G inverse of fx, my fx is x plus 1 over x minus 2. I'll do G inverse of this. I'm writing here only because the screen space is limited. You can write on the next line when you're writing in the paper. So if I put this in the G inverse, you'll get x plus 1 over x minus 2 plus 1 over x plus 1 upon x minus 2 minus 2. You can put the brackets, you can take the LCM upon 1, my LCM would be, of the numerator would be x minus 2, this will be x plus 1 plus x minus 2 divided by x minus 2 is the LCM, x plus 1 minus 2x plus 4, this cancels off, so you'll be left with 2x minus 1 upon 5 minus x. And obviously your implied domain, so G inverse of fx is equal to 2x minus 1 upon 5 minus x. My implied domain denominator cannot be 0, so x cannot be 5, that's the implied domain. Part B also I'll show you the easiest method to do it. There are people who have done a lot of things for this, but it's not as difficult as people have made it to be. What you need to do is, when you get a sum of this sort, you can take this f inverse on the other side as fx. So your f inverse will go on the other side as f3. So GA is equal to f3. So now your GA, if you use the definition of the function, it becomes 2a plus 1 upon a minus 3 is equal to, my f3 would become 3 plus 1 upon 3 minus 2. So you just solve for a. That's it. That's your answer. So this is 2a minus 3. So 2a plus 1 is equal to 2a. 3 2s are 6. Beg your pardon, this is 4. This is 4, I made a mistake. So 4a minus 12. So 4a minus, this is GA is a minus 1. I'm making a lot of mistakes. Okay. So yeah, so a minus 1. So this becomes minus 4. So 5 is equal to 2a. So a is equal to 5 upon 2, or a is equal to 2.5. Now part C, what is the special name given to the function fogx? This is a special name. You can't call it a composite function. So if you try to find in fogx, so f of gx, so if you do f of gx, so your gx is 2x plus 1 upon x minus 1. So if you work it out, so this will be 2x plus 1 upon x minus 1 plus 1 upon 2x plus 1 upon x minus 1 minus 2. If you simplify this, this is 2x plus 1 plus x minus 1 divided by 2x plus 1 minus 2x minus 2, because then your x minus 1 denominator cancels off. And I'm doing number of steps together. You can write all the steps if you want. Okay. So if you do this, so this would be plus, because yeah. So this would be 3x upon 3. So x. So basically fog x is equal to x, and this is called the identity function. So y is equal to x is called the identity function, which children don't remember this name. The last sum for the test involves the definition of quadratic. Now if anything is concave up is like this, means your coefficient of a, the coefficient of x square would be positive. So that means k is greater than minus 1. So that's my part A, which was easy to get this 1 mark. Now cut the line y is equal to 0. Y is equal to 0 is the x-axis at two distinct points. That means your b square minus 4ac should be greater than 0. So b square minus 4ac is greater than 0. If you solve this, b square, so if you look at this, this is my a, this is b, and this is c. So b square minus 4ac is greater than 0. So 4k square minus 4, this is k square minus 3k minus 4 is greater than 0. So when you open the brackets, 4k square minus 4k square, 12k, and this is 16 is greater than 0. This cancels off. So 12k is greater than minus 16. So k is greater than 4 4s are 4 3s are 12. Yeah, this is one of the solution. But remember, for the quadratic to exist, a cannot be 0. So your a is your k plus 1 cannot be 0 for the quadratic to exist. So k is not equal to minus 1. So if your k is greater than minus 4 by 3, at the same time, your complete answer would be this is greater than equal to this is greater than minus 4 by 3, and k is not equal to minus 1. This is my complete answer. So if you getting this 2 marks, you have to mention this as well. Otherwise, you just get 1 mark. Tangential to the x-axis. Tangential to the x-axis means one solution, equal roots. B square minus 4ac is equal to 0. B square is equal to 4ac. The same way you can solve, and you'll get your k is equal to minus 4 by 3. Part B will not cut the x-axis at all. Means your b square less than 0, imaginary roots. So that means your k will be less than minus 4 by 3. Okay. So this was the test solution.